Linux commands. In the following procedure, we'll work with these commands: ifconfig, ping, traceroute, dig, and finger. Currently, I'm running a version of Linux known as SUSE, but you can use any version of Linux that you want. The commands will work pretty much the same way. I've opened the command line interface, and the first command we want to run is ifconfig. That's the interface configurator, and it's a lot like the Windows command ipconfig. If we type that and press enter, we'll get some information about our network adapters. For example, ETH0. This is my first network adapter, and we know it's an Ethernet adapter, first of all because it says ETH, but also it tells us the link encapsulation type is Ethernet. That's the network type. The hardware address, or the MAC address, or physical address, is here as well. And then the iNet address, which is the IP address, 172.30.250.5. The mask over here, which Windows would refer to as the subnet mask, 255.0.0, so we know it's a Class B default subnet mask. And the broadcast address. Well, we're on the 172.30 network, so the broadcast address would be the last IP in the range, which is .255.255. It also shows the amount of packets that were received and transmitted. In addition, we see the local loopback adapter. You remember 127.0.0.1. So a lot of information from ifconfig. But ifconfig does a lot more. We can look at information for a specific adapter by just typing ifconfig and the name of the adapter, like ETH0. When we press enter, we just get information for that one adapter. You can also enable or disable adapters. If we were to enable ETH0, we'd type ifconfig ETH0 up. If we wanted to disable it, we type the same thing but with a down on the ends. If I down the adapter and I do an ifconfig, you'll notice that it doesn't show any information for that adapter anymore because it is disabled. Only the local loopback is showing. So I want to bring that back up, and if I run the ifconfig again, we see both adapters, ETH0 and a local loopback. You can also set IP addresses with the ifconfig command. Let's say I want to set the IP address of ETH0. I would type ifconfig ETH0 and the IP address that I want, for example 172, while I type correctly, .30.250.254. Then we need to know the net mask, which is going to be 255.0.0. Press enter, and it doesn't really tell you anything. As long as you don't get an error, you're in good shape. That IP address should now be applied. To find that out, we'll run an ifconfig again and take a look, and here's the IP 172.30.250.254. You can also add a gateway address if you wish, but you wouldn't use the ifconfig command. You'd use the route command. Now if we just type route, it'll show us our routing table. It may take a few moments for this to come up, but it'll show what networks we have the ability to connect to, those are destinations, and what the gateway address is that we use to get there. Right now we have the ability to connect to the 172.30 network and the loopback network, which is basically 127. If I want to add a gateway to connect to specific networks, I would use the route add command, and then I would specify default GW, short for gateway, and then the IP address of that gateway, which is .1. We'll press enter. Again, no errors, so it looks like it went through okay. We'll type route again to take a look at the routing table. Again, that's going to take a moment to come up, but we should now have that interface added to that network. So let's take a look. Here we go. The default gateway, 172.30.250.1. I need that to communicate beyond this network. If I want to communicate to the internet or other networks, I need that gateway to get out. Okay, now to get a dynamically assigned address again, you got to remember, if we do an ifconfig, I've applied this IP address. But if I want to get my dynamically assigned address again, I have a couple choices. First, I could either restart networking, and I would do that by typing /etc/inet.d/network restart. That's going to shut down the adapters, and then it's going to bring them back up, and you can see right now ETH0 is looking for the DHCP address. Let's see if it found it. We'll do an ifconfig again, and it did. It picked up its original DHCP address, 172.30.250.5. So you can either restart networking with that original command that I just mentioned, or you could go ahead and restart the system. Now, if the IP configuration file is set to static, you'll need to reconfigure the network script option, and it's called boot proto, and you'd want to set that to DHCP. We can also specify DNS servers, and to do that in the command line, we can modify the resolve.conf file, and we do that by typing vi/etc/resolve without an e .conf. And that gives us a lot of information here, and if we scroll down a little bit, if we arrow down I should say, it'll show us the name servers. From here we can make modifications to those. So for example, I may want to change the name server from .1 to say .2. I'll press the insert key to make changes and replace .1 with .2. I'll press escape to go back into command mode, and then to save this I'm going to type capital Z twice, and that brings us back. So now we've made some changes to our DNS servers. And by the way, ZZ, capital ZZ, saves and quits out of that file, or you could just do :W to save, or :Q exclamation point to simply quit. So we can make a lot of changes with IP, gateway addresses, and DNS within the command line. If you want to find out more about the ifconfig command, we can run an ifconfig --, which will give us some basic information about how ifconfig works. Or you could use the manual page. The manual pages within Linux give more information. They give a very in-depth explanation of how the command works. So for example, we type man space ifconfig, and that'll give us the entire manual page for that information. If you want to get out of the manual page, you could just type Q, and that'll bring you back to the prompt. There's manual pages you can get online as well. If we go back to our other computer here, you'll notice I'm at a manual page at linux.die.net, or you could go to freebsd.org. There's a lot of different places where you can get these manual pages. Sometimes it's a little bit easier to read it in a browser than it is in the command line. Next is ping, and we've used this in Windows, and it works pretty much the same way in Linux. If we run a ping space --, we'll get the basic usage for ping. But for more in-depth information, you can type man space ping, and that'll bring up the manual page, which is also available online. Pressing Q gets us back to the prompt. Let's try a ping space localhost, and we get replies from 127.0.0.1, and you'll notice that the replies are continuous. To break out of this, we need to press Control-C, like so. Now in Windows, you would use the -t parameter to accomplish this, but it's set up by default in Linux, which is a pretty nice feature. Now if you want to specify the amount of packets, you could use the ping-c parameter, and we'll say 10 packets, and then the IP address of the device we want to ping. That'll ping that device with 10 packets exactly. So good for testing. Next, let's try pinging a website. We'll do davidlprouse.com. That's going to go out through the gateway, and it's going to resolve davidlprouse.com to its IP address, and then we should get replies from the Lunar Pages server where David L. Prouse is stored at. So you see a lot of resolution going on here. To remove the middleman and do it numerically, we could use the -n parameter. And when we do so, it's still going to have to resolve to IP, but then those replies are going to come as IP address. It's not going to resolve for everything else. So you can see here we're getting the IP address coming back. Finally, if you want to increase the packet size, you can do so with -s. By default, the ping will send 56 bytes of ICMP data encapsulated in an IP packet which is 64 bytes. If we want to change that ICMP size, we can with the ping-s, and I'll change it to say 120, and the IP address of the device we want to ping. You'll see here that it shows 120 and encapsulates that in a 128 byte packet. So the parameters you want to know: -C specifies the packet count, -N specifies numeric only without name resolution, and -S will specify the packet size. Here's an example of a man page online for ping. Another command we can use is Traceroute, and I'm going to run a traceroute to davidlprouse.com. Traceroute is the equivalent of the Windows Traceroute command, so only Traceroute works in Linux. And what this is going to do is it's going to trace the entire path from my computer to the final destination, which is davidlprouse.com. It'll look at each hop or router along the way and test each of those routers with 3 pings. Now you can see here it's tracing to davidlprouse.com, it's resolved the IP, and we're starting to see each entry here. And each one of these routers is being hit with 3 different pings. I'm going to Control-C to break out of this, and to get the information a little bit faster, we can use the -N parameter. The -N parameter is short for numeric, and this allows us to get the information and kind of cut out the middleman, cut out the name resolution, so that we get the information just with IP addresses in the results. Now in Windows, this would be the -D parameter. So again, a slight difference here. And boom, all the information is piling in now. You can see the IP addresses and the 3 pings for each. And if you wanted to do this with IP version 6, you would use the -6 option after the traceroute command. There's another command called MTR, and MTR is available on newer versions of Linux, which is a network diagnostic tool that combines the functionality of ping and traceroute. Let's try another command. Next is dig. Dig is the domain information groper, and this takes the place of NSLOOKUP. We're going to try a dig to davidlprouse.com, if I can type it. Dig davidlprouse.com, and you see some information has been given to us from the name servers. In the answer section, we see here that this is an address record. I know that because it says A for address record, and it resolves the name to the IP address. It also shows us the name servers that are doing this name resolution. NS stands for name server, and these are the Lunar Pages name servers right here. You could also use a command host space and the name of the domain, and that'll resolve that to IP address. Something close to that would be dig and the domain name and the +short option, which just gives us the IP address. And we can build on that by adding the +identify option. That'll give us the IP address and tell us where it came from, what name server was actually resolving that. You get some different records here. You want to know that A is an address record, NS is a name server record, MX would be a mail exchange server, and SIG would be a signature record. And last command for now is going to be finger. Finger allows us to look up information about users on this computer or on remote computers. So for example, the default user in Linux is going to be root. So I'll finger the root user, and we'll take a look at what we get. Here it says the login is root and the name is also root, no difference there. The directory where information is stored, and it shows when the person has been on since and whether or not new mail has been received or read. So you can find out the last time that a user logged in with this. I'll do it to another account. We'll do David P, and you'll see that David P has never logged in. And you'll also notice the name is David L. Prouse for that user. You can also show the real name and where they've been with the -S parameter. And that'll show where they've logged into and where they've been. Now with David P, there's no logins, but we can do that with the root account, and it shows us that the account has just been idle for now, but otherwise it would show where that account has gone to last. You could also finger accounts on domains or on other computers. So we could do something like finger a specific user at a specific domain, like dpro.com. But you have to be a member of that domain or have a connection to that domain through DNS to get that information. So there you have it. There's some commands within Linux. Let's show an example of SSH. In this procedure, we'll enable SSH on our Linux computer. We'll show how to download and install OpenSSH for Linux, and connect to the Linux computer from Windows XP using a program called Putty, which will utilize the SSH protocol. So first I want to go to the Linux computer, and I'm using SUSE, which actually has SSH installed already. If you want to make sure that the SSH protocol is started, we can do that in the command line with a /etc/init.d and the command sshd space start. When we press enter, it starts the SSH daemon, which now will allow incoming connections from other computers via the SSH port and protocol. Now I want to test and see if this is really running from an external computer, so I'll go back to the Windows XP computer, and we'll go to the command line, and I'm going to run an NMAP scan. So we'll do an NMAP-S, capital S, and the IP address of the Linux computer. That's going to start up the scan. It's going to ping that Linux computer, and it may take a moment because that Linux system is actually running as a virtual machine on another computer. So that'll ping that virtual machine, and then it'll start the scan of all the open ports. You'll notice that there are less open ports here than you would normally see on, say, a Windows client. And here is port 22, SSH. So it is running. So let's go back to the Linux computer, and of course if you wanted to stop the service, you could just change that path and use the stop command. Okay, next I want to show you how to download and install OpenSSH on Linux. Now again, a lot of Linux computers come with OpenSSH installed. You may want to upgrade to the latest version, or maybe you're using a version that doesn't have OpenSSH. We can go to our browser and we can go to openbsd.org, and they have an FTP site with all of the particular download versions for OpenSSH. The one I want is OpenSSH 5.1 P1, and we're using a tar.gz. So we'll press enter for that, and we'll select save as, and we'll save that right into the root for now. That's going to begin downloading that file. Okay, here we go. I'll copy that file over to my machine. And then from there, what we want to do is we want to decompress and extract the contents. So we'll do that in the command line. So we'll go back to the console, and if I run a dir, we should see that file, and you can see it's the last one on the list in red, OpenSSH-5.1 p1.tar.gz. So it's a tar, so it's a bunch of files put into one, and also it's a gz, so we know it's compressed. So we're going to use the tar command, and we'll run the parameter xvzf, and the name of the package, which is OpenSSH-5.1 p1.tar.gz. Okay, that extracted all the contents. It extracted them and decompressed them. And if we run a dir again, we'll see that not only do we have the file there, but right above it we have the folder called OpenSSH-5.1 p1. Now we want to move over to that folder. We'll do it with a cd, OpenSSH-5.1 p1. And we're in that folder now. And from here, if we want to run the program, we can run sshd, and that'll start up the SSH program. Now you may want to go further with this. You may want to repackage the program. You may want to place it in a different folder, etc. So there's more possible configurations here. Also, there's other versions of SSH. There's pay versions, like the versions at ssh.com, but a lot of Linux computers use OpenSSH, which is a free version available at openssh.org. Now what I'd like to do is I'd like to connect to this Linux computer with my Windows XP client. So we'll go back to the Windows XP client, and I want to go to the Windows Explorer, and the program I want is Putty. So I'm going to use Putty to connect to that Linux computer via SSH. We'll double click on that and run it. And now it's going to ask us for the host name or IP address of that computer. So we'll type that in, 172.30.250.5, and we'll connect. That brings us to a Putty screen. It's going to tell us to log in. I have multiple options. I'll just use root for now. And then it's going to ask for a password. We'll type that in. And we're connected. Have a lot of fun. That's the message they give you by default. So now we're connected, and we can control this Linux computer from the command line remotely. So if I wanted to run, say, an Ifconfig, I can see the information about that computer. I can change folders with the cd command. I can run commands with vi. So a lot of different options here. And what I'd like to do is I'd like to view this connection with the netstat command. So I'll go back into Windows XP here, into the Windows XP command line, and run a netstat-an, which I'm a fan of since it's numeric. Information comes up relatively quick. Here's the remote computer, .5, that's the Linux computer with port 22 SSH open. And here's my computer connecting, and it's using a dynamically assigned port 1399. Now, if you'd like to know whether or not the connection is secure, you can use a network monitoring program like Ethereal and view the SSH packets. In this case, they're going to be SSH version 2 packets, and they're going to be secured packets. There's a lot more options with SSH, from generating keys to lots of configurations you can do on the server and the client side, but just wanted to show you a basic SSH connection to a Linux computer. Okay, let's summarize what we did in Lab 17. In this lab, we demonstrated the usage of various Linux commands like ifconfig, dig, traceroute, and ping, and finger. And we increased your knowledge of networking with a Linux computer. Then we demonstrated SSH in action by connecting with the program known as Putty to our Linux computer. And of course, other programs are available to connect via SSH. Up next is Lab 18, Configuring and Securing Firewalls.